Thank you.
Hi.
Thank you, Linda. Hi to everybody. Nice to join you for this webinar. As Linda said, I'm the commercial director of Bram-Cor. It's an Italian company. We are specialized in pharmaceutical equipments and line, mainly devoted to the production of large volume parenterals and focused on water treatment systems. Today, I would like to give you an highlight on the 3 technologies that are allowed for the main rules for the WFI production, for sterile production. So, can I start?
Yes, please go ahead.
Thank you so much. So, the technologies for WFI production for sterile injections are today in the most part of the world 3. 2 are in the family of the distillation, so the multi-column distiller or multiple effect distiller, and the vapor compression distiller. There is another alternative, quite young, at least for the European market, that is the membrane WFI. That is a cold system for producing WFI. First of all, what is WFI? WFI is the water for injection. There are a rule and definition by USP and European pharmacopoeias that are the 2 kinds of pharmacopoeia that are, let's say, more recognized worldwide. There are some slight differences between the 2 pharmacopoeias. For the American pharmacopoeia, the conductivity has to be 1,3 at 25 degrees. For the Europeans, it's 1,1 at 20, but you know that the conductivity can be compensated by temperature. For the pH, aerobic bacteria, TOC is the same requirement. For the endotoxin, there is a different way of measuring between the 2 systems, but we are talking about 0.25 of EU for USP and IU per milliliter for the European pharmacopoeia. Nitrate are recognized just from the Europeans, that is 0.2 ppm, and the same is for the heavy metal, that is 0.1 ppm. So let's say that which is the main difference between the compendial water or fluids recognized by the pharmacopoeia. The first is the purified water that is used for products in contact with the mucoses, so eyes, nose, ears, and mouth, that is produced normally by reverse osmosis system. And then there is the WFI. The WFI is mainly for the removal of bacteria and endotoxins, and historically or traditionally, at least in this part of the world, was obtained by distillation. Why? Because any body or any alive body on the planet is quite sensible to high temperature, and it is quite safe to kill them by heat. The difference between PW, because of the body, the human body tolerance in that, between PW and WFI in bacteria is 1,000 times. So the content of bacteria allowed in the PW is 1,000 times higher than in the WFI, because our body is clearly more ready to accept them through the mucoses than internally in the blood. There are some characteristics in the feed water for the 3 technologies that I repeat are multi-column distiller or multi-effect distiller, vapor compression distiller, or membrane WFI, that is a reverse osmosis electrode ionizer plus an ultrafiltration module. What I am indicating here are the recommended in-feed conductivity and elements to run the machines. In the reality, the technology are some more tolerant in that, but we are always trying to balance the characteristic of the feed water together with the maintenance and the lifetime of the machine. Just to give you an example, you see in the second line, DCS, so the vapor compression distiller, we indicated equal or less 200 microsiemens in feed water inlet. In the reality, the machine is much more tolerant. We have some customers that are using 300, 400, or even 500 or 800 microsiemens obtaining WFI. But clearly the machine is much more stressed. The stops for cleaning, descaling, etc., are much more frequent. So you have a stop in production with losses and so on. And so we tried to balance with a recommended characteristic for the feed water. So typically, the multiple effect distiller is recommended to have PW as for the USP, so 1,3 microsiemens at 25 degrees, 0.5 ppm. Chlorine has to be completely absent, recommended clearly. The aerobic, the total bacteria count less than 100 CFU per milliliter, and the hardness 0.1 ppm as CaCO3. It means really purified water as per USP. For the vapor compression distiller, we have more tolerance, 200 microsiemens of conductivity at 25 degrees. We have 125 ppm of TDS. The feed chlorine can be 0.1 ppm, still very low. Same conductivity, so same total bacteria count that we found in the multiple effect distiller, and 1 ppm of hardness. For the what I have indicated as reverse osmosis plus electrodionizer plus ultrafiltration skid, clearly we have more or less the same characteristic that we have in the PW generation. So 1000 microsiemens at 25 degrees of feed water. The TDS that is related to the conductivity, it's about 600 ppm. The same content of free chlorine of 0.1 ppm. Total bacterial count is the identical one to the others. And we have the possibility to have an hardness that is 1 ppm as CaCO3. These are the three characteristics. As you see, the multiple effect distiller is the one that is more, let's say, tight in accepting variation or in quality of the feed water. Averagely, the vapor compression distiller quite wide, the reverse osmosis, the membrane W. We all know why the pretreatment is needed for the reverse osmosis, because the PW generation teaches us the reason why we have to do that. We can summarize. When we talk about membranes, we have very tight porosity in them. So we have to remove all the elements with the pretreatment, all the elements that can create scaling or some chemicals that can damage the membranes, or we have to control the temperature to maintain the life of the membrane in the long term, and keeping the temperature that is not good for bacteria proliferation, etc., etc., etc. So when we talk about membrane WFI, the pretreatment is more or less the same or the same that we have for the PW. When we talk about the distiller, we are talking about thermal machines. So the typical pretreatment change a little bit depending on the technology that we are using, vapor compression distiller or multi-peptide distiller. So the machines are subjecting to scaling, for example, with hardness, calcium, magnesium, or silica, that especially the colloidal silica, and or corrosion. For example, an excess or the presence of chlorine. The chlorine, especially its gases with the stainless steel, can create the phenomenon of pitting that is creating some pointing, some stains on the stainless steel. So the pretreatment becomes fundamental for the quality of the WFI that we obtain, and also to preserve the technology, the machine, in the medium long term. So the two differences between the distillers is that the vapor compression distiller is operating slightly above the atmospheric pressure, so we can consider it an atmospheric machine, and it's quite more tolerant, as we have seen in the previous slide, in the feed water characteristic. The multi-column distiller is a technology that is working with much higher pressure and then much higher temperatures. And so it is more subjected to the variation of the feed water. And it is requiring higher quality of feed water to prevent scaling and cold. The typical multi-column distiller pretreatment is then, as we have seen before, the characteristics are practically those of the PW as per USP indications. The recommendation is always to start with potable, drinkable water as per WHO or EPA, depending from the part of the world, and then to pre-treat the water, normally with softening. So let's say calcium and magnesium removal, chlorine removal, thermal tempering, and then all the filtration or dosing station that are required. Then we can have or a double pass RO or a single pass plus electrode ionizer, and then we can go to the multi-column distiller, multiple effect distiller. So we are practically to provide a complete system for PW generation as per use. When we talk about the vapor compression distiller, as we have seen before, there is the summary on the top, we have a higher tolerance in the characteristic of the feed water. We always recommend, let's say the rules always recommend to start with potable drinkable water as per WHO or EPA. Let's say that 200 microsiemens of conductivity allows to work in some cases just with softened water, dechlorinated water, and go into the machine directly. Clearly, it depends always by the characteristic of the raw water from the municipality. We, in any case, recommend always to add at least one single pass of reverse osmosis, even industrial type, because it's a pretreatment, in order to be safe, especially in the areas of the world in which the fluctuation of the raw water quality, the municipality water quality during the seasons is quite high. But in any case, we have customers that are using softened dechlorinated water only to feed the distiller. obtaining WFI. Obviously, the higher is the conductivity that you inject in the distiller, the higher will be the rejection of the concentrate, and the more frequent become the cleaning. 200 microsiemens, 150, 200 microsiemens allows, like in the multiple effect distiller with 1,3 or below 2 microsiemens, to have a quite long possibility to work without having intervention to be done for descaling or cleaning or etc. So as you see, there is the source, softening, chlorine removal, single pass RO recommended, and you can go in the vapor compression. When we talk about the membrane WFI, as anticipated, we are talking about the PW system with an ultrafiltration module at the end with certain characteristics added in order to make the machine safer than a PW generator. But more or less, the feed water characteristics are the same. The recommendation is always the same, starting with drinkable potable water. Conductivity, we recommend to have 1,000 microsiemens, but it depends from the city water. TDS 600, so the same thing that we have seen in the previous scheme. The standard pretreatment is usually for that kind of feed water, microfiltration, softening, dosing station. So we are talking about, for example, NaOH or anticoagulant or any kind of dosing. Also for chlorine removal, I have separated in the scheme the chlorine removal because the chlorine removal can be obtained by two ways, two technologies. One is the sodium metabisulfite dosing, the other one is the active carbons. Also, in this case, it depends from the raw water analysis or the preference of the customer. Then thermal tempering, and then we have reverse osmosis, electrode ionizer, and ultrafiltration. Coming a little bit more in detail of the technologies, we have the multiple effect distiller. You probably know it is the distiller that I can say is the most known in the world. The production of this machine is practically everywhere on the globe. You can find them in Asia, in Latin America, in Europe, in the US. It's quite common. However, it's a system that incorporates evaporative heat exchangers, separator, and condenser for the condensation process. Typically, it is called multi-effect distiller or multi-column distiller because it operates in a range of 3 to 8 columns. There is the possibility of the single effect distiller, also that is a single column, as the name says. So typically, depending from the capacity, is from 3 for small capacity up to 8 for large capacities. It is a pressurized machine, as I was anticipating before. So the higher pressure of industrial steam for heating you give, the littler is the smaller is the machine, and the lower pressure you give, let's say, the less efficient is the machine itself. Just to give you an example, the same model, if it operates at 5 bar, it will be able to provide a certain capacity. If you have the same model of the machine heated by 8 bar, the capacity of the machine will be increased. One of the characteristics of this technology is that the quantity, the pressure of industrial steam are quite significant. There are some ways to reduce the impact of them, that is to add preheaters on each column or to increase the number of the columns. So clearly there are solutions, but we are talking about standard condition. And it requires normally cooling fluid, so chilled water or cooling water, to condensate the dry pure steam produced in WFI. Also, in this case, we are generally speaking, if in certain cases, increasing the number of the column till a certain point, the consumption of cooling chilled water can be zero. Then again, as we said before, there is to think to the OPEX, CAPEX balancing, because sometimes the increased number of columns make the machine very expensive and maybe cannot compensate the use of chilled water. In any case, these are part of the 20% of the casuistic of the cases that are not re-entering in the standard condition that we are checking and evaluating today. The capital cost increase during operation, as I was saying, steam and cooling fluid consumption, and decrease are as the number of effects are added to the multiple effect. The more column you have, the less consumption of utilities you have, as we were saying. Another thing that has to be notified is that being a pressurized machine, it is subjected to the coding, for example, to the PED in Europe and the IASB, the EU stamp in the US, that are having an economic impact on the machines. The WFI is discharged atmospherically, so typically require a pump to transport the WFI to the storage tank, or the storage tank has to be at a lower level of the WFI outlet of the distiller itself. This is a scheme, a simplified scheme of a multiple effect distiller. Again, we are talking about the 8% of the casuistics. There are possibility to customize the machine in several ways, but we have the heating media, typically industrial steam, as we said, from 5 to 8 bar to have a quite efficient machine that heat the feed water, the purified water in the first column, creating dry pure steam that is used in the second column to heat up the PW present in the second column. That will create, again, dry pure steam to heat up the PW that will be in the third column, and so on. It means that, as we were saying before, this machine is using every column, every effect of the technology in order to reduce the consumption of industrial steam, optimizing the efficiency. Then, when we have created the dry pure steam from the last column, we have the condenser and the other exchanger, the cooler, in order to condensate the WFI, sorry, the PES, the pure steam in WFI. Typically, this machine works with WFI outlet at 99 degrees. Also, in this case, I'm talking about what we think it is optimal, not to have a too high consumption of cooling chilled water. It is possible clearly to reduce the temperature to 90 or 85, but we think that considering that there is the looping system with exchanger, it is better to control the temperature in the looping system. Again, to balance the consumption of cooling water. Vapor compression distiller is a system, a technology in which the water evaporated inside or outside the bank of tubes that are arranged in the vertical configuration or in the horizontal configuration. Let's say that typically, as all the evaporating machines, so distiller to steam generators, is a vertical machine, but we can find on the market some horizontal machines, both for WFI production and for PS production. So we are just noting also this point. Let's say that coming to the previous ISPE description, the vertical design is the natural circulation type. Clearly is a distiller, so there is water that evaporates in steam, and the steam clearly has the tendency to go up, being lighter that water. And the vertical configuration allows a natural separation between steam and water particles, also by gravity. The horizontal design is clearly a forced circulation and recirculation, and it requires pump and spray nozzle because you cannot clearly use the natural gravity separation for that. One of the characteristics that we have indicated before is that the vapor compression distiller is operates at a slightly atmospheric pressure, a little bit over zero. The industrial steam pressure is then lower than the one required for the multiple effect distiller, typically. So 3 bar or even some less. It is more common to have a vapor compression distiller that can be heated by steam, electricity, or even both of them. You can select the sources, for example. Clearly, it depends from the country, the cost of energy, the availability of energy, or the policy of the company, etc., etc., etc. In Europe, but also in certain countries in Asia, we are seeing that the tendency to go to electrical heated machines is increasing. It is possible with the vapor compression distiller. In a certain way, it's possible also with the multi-column distiller or the single column distiller. Let's say just that is more typical to find this kind of solution in the vapor compression distiller. The vapor compression distiller is not requiring cooling water to condensate the WFI from the pure steam. So you don't need chiller or tower water, etc., etc. And because of this design, the WFI is not coming out at atmospheric pressure, but is a little bit pressurized at 1.2 bar averagely. It means that you can have a certain push from the distiller to reach the tanks. So I'm going a little bit more in this technology because it is taking market share in the distillation family, but is not so present worldwide as the multi-column distiller. So I show you a scheme. In this case, we have a distiller that is also able to produce cold WFI. You have in the big column, in the bottom part, you see that we have the industrial steam that helps to heat the feed water. That I remember is possible. Our recommendation indicates up to 200 microsiemens, more or less. It means that the machine to provide the correct feed water to this kind of distiller is not so, let's say, articulated or expensive like the one required to the multiple effect. The stuff starts boiling, goes into the tube, then it evaporates in steam is still a, let's say, wet steam. So in the wet particle, to make it simple, we have the contaminants that are remained. The first separation, as we indicated before, is by gravity. Then there is a baffle on the top in order to separate the remaining particle of the droplet or the water in the steam, obtaining dry pure steam on the top of the big column. The temperature at that point is over 100 degrees, but is not so high temperature. So here we have the scope of the blower or the compressor, depending on the technology of the manufacturer. In our case, it's a blower. It starts to rotate, aspiring the dry pure steam and compressing it. This is the reason why the technology is called thermocompression or vapor compression. And for the second physical effect, before we had the gravity separation, we have another physical effect that is the compressing of a gas. You know that compressing a gas, the resistance between the molecules increase, and you increase also the temperature. So we can reach higher temperature internally to the compressor, depending from the speed of the compressor, the manufacturer, the capacity of the machine. The temperature can vary a little bit, but this is the job of the compressor. Then it blows this dry pure steam in the external part of the exchanger, the condenser that we have in the big column, having a thermal exchange. It means that we are using the dry pure steam to help the purified water to evaporate, and in the same time we are using it to start to condensate the pure steam in WFI. So it's a thermal exchange. Then we pass, as you see, there is a pump and a tank. We pass that semi-condensated WFI in this system, practically with a double effect. The first one is to strip out the incondensable gases. The second one, it will give that pumping to the WFI that we were mentioning before, for which the vapor compression distiller is giving WFI at 1.2. At the end, you see on the left side of the machine, we have two exchangers. Typically, the standard machine has one of them, and it produces and condensate WFI at 99 degrees, like more or less the typical multi-column distiller. But adding a second exchanger, as in this case, we can have various solutions that are the possibility to control the WFI temperature. In which way? We decide to have WFI at 85 degrees, no problem, we can set it at 70 or whatever is the temperature, again, without the necessity of cooling water. So that part in the vapor compression distiller is not necessary. At least up to a delta T of 10 degrees more than the feed water. I mean, we do not need any cooling water to control the temperature of the WFI coming out from the vapor compression distiller if we produce WFI with a temperature that is up to 10 degrees more than the feed water. So if the feed water is 15 degrees, 1.5, we can obtain WFI from 25 up to 95 degrees without the necessity of chilled or cooled water. Clearly, if we reduce the delta T of 10 degrees, so if we want to obtain WFI at 20 degrees, having 15 degrees in inlet, at that point we need clearly some cooling water, but it's quite a bit. Then we have the membrane by WFI. I would like to spend some word on that, because for the Europeans, it's, let's say, a quite new application, not technology. It's a quite new application. It's allowed in Europe from 2017, if I'm not wrong, as application for WFI. We had this kind of technology before, but it was used for highly purified. From 2017, the European pharmacopoeia decided to be aligned with other pharmacopoeias in the world, for example, USP or the Japanese one, that are allowing this technology for the WFI product. For us, the WFI was typically for obtained from distillation, but now it's a technology that is allowed also in Europe. Sorry, an application, because the technology for us was already known for an application that was an intermediate level between PW and WFI, that was HPW. Which are the main benefits of this technology, and the reason why we think that it found application also is the increased sensitivity that in the world is grown for the investment and the green system at a certain point, or the energy consumption. This is, under a certain point of view, the reason why this system is starting to be accepted also in the pharmaceutical world, because clearly we are talking about a system like the PW generation, maybe with some adjustment, like it is recommended to have, in any case, hot water sanitization, certain controls, and it is required to have an ultrafiltration module after the electrode ionizer. Let's say that it is clearly a PW system, as we have seen in the first slide. A PW system normally allows a 1,000 times higher level of bacteria. So the ultrafiltration module at the end of the machine is, let's say, used to control this kind of system of bacteria level. But typically we have a PW system at the top of its design with an ultrafiltration module at the end to control the excess of bacteria and endotoxin. The membrane operation is, as we have anticipated or mentioned it before, the raw water. We have the pretreatment, as we say, the calcium removal, chlorine, sodium dioxide, etc., filtration, control of the temperature, so maybe exchanger in order to have the right temperature, then reverse osmosis, possibly degassing, depending again from the raw water, electrode ionizer, UV lamps, also in this case, depending from the raw water analysis. This is a simplified scheme. There is the possibility of a PW purified water tank or a break tank, then the ultrafiltration module. If it is necessary, another UV lamp and water for injection. So as you have seen is, but for the ultrafiltration at the end, a PW system at its top of the design. Which are the advantages of or the disadvantages of the three technologies? To have a summary of what we have said. The membrane WFI has a low energy consumption. This is probably the one of the two main benefits that the technology has. It has consumption of industrial steam only during the hot water sanitization phase. The investment is, let's say, some lower because you have just the reverse osmosis plus the ultrafiltration skid module. Meanwhile, for example, in the multi-column distiller, you need this system plus the distiller. In the vapor compression distiller, we will see we have seen that you do not need a reverse osmosis plus electrodynalyzer, but something less. But in any case, you have reverse osmosis, a recommended reverse osmosis plus pretreatment, and the distiller itself. It is clearly fantastic for the cold WFI production. And the risk of the rouging, that a phenomenon, for example, that is extremely present in the thermal machines, let's say very common, is practically zero. Which are the, let's say, disadvantages? That it is directly, the production of WFI is directly connected by the raw water source. So the pretreatment has to be designed very properly on the worst case scenario. There are various instruments to be calibrated. The control of microbiome content is increased because, again, there is not an interval with a boiling system, but everything directly flow to the WFI production. So it is important to have that. There is the use of chemicals. I would like to say, again, because the flow is direct from the raw water to the WFI without a stop in the middle with the control, for example, through boiling, as it happens in the distiller. There are maintenance for consumables, replacement, filter membrane, etc., etc. It has to be recirculated continually. The integrity test of the ultrafiltration is required. Desanitization is maximum 80 degrees, 80, 85. There is the necessity during hot season to keep the temperature below, we recommend below 20 degrees to have an environment that is not good for bacteria proliferation. So you need cooling water in the exchanger for maintaining the water cold. And clearly, if you need to heat up, in the case it is required to heat up this WFI at high temperature, there is the necessity, a quite high important necessity to use industrial steam, and it is a quite high consumption. For the distiller, which are the advantages and the disadvantages, multiple effect distiller, as we said, is simple and very well known technology. From the first column, being a pressurized machine, it is possible to obtain dry pure steam in pressure. So the same machine can be a distiller, but also a pure steam generation, again, under certain conditions. We are generally speaking again. Is very good in the microbiome control because it works at very high temperatures. It can be sterilized, 121 degrees. And as we said, the key points, at least under our point of view, for WFI is the bacteria and endotoxin control. And it is clearly suitable for hot WFI production. This is quite obvious. The disadvantages, high initial investment. As we say, you need more or less the same technology that is used for the membrane manufacturing, the WFI membrane manufacturer, plus the distiller, plus a series of ancillary systems to make it work. So the boiler, for example, quite performant boiler, because the higher is the pressure of an industrial steam, the higher is the capacity. The cooling system that can be a chiller with its distribution, or tower water with its distribution. So the system itself. It is recommended for the long life of the machine and the performing of the machine to PW. We recommend as per USP. In the standard machine, the consumption of cooling water and industrial steam is higher than in the other technologies. It is, as we said, a machine that has very high temperature, so the risk of rouging is quite high, or higher than in other technologies. It's quite limited in case you want to change, to have a flexibility in the output volume, and it's high pressure operation. So as we mentioned it before, it is subjected to regulation, for example, PED in Europe, and use standby as mean in the US. Vapor compression distiller, which has the advantages and disadvantages. Let's say that is a technology that we have seen in the story that is quite robust and long-lasting one. I would say that we have still customers that are working with machines, vapor compression of the late 80s or the 90s. It is not so common, at least in our experience, to find the same for the other technologies. The microbial control is excellent, again, because it is boiling and no bacteria or alive bodies can resist to high temperatures, the same of the multiple effect distiller. It is good for the hot or cold WFI production, but without cooling water, as we said. It doesn't need cooling water for distillation. The feed water inlet in the machine has not to be pressurized. Normally it's 0.5, 1 bar only. Meanwhile, I forgot to tell this, it is required to be pressurized in the multiple effect distiller. The output of the WFI is pressurized, as we said. Industrial steam consumption is typically quite low because of the various thermal exchanges that we have seen in the phases of the machine. The pressure of the industrial steam is low, 3 bars, so the boiler is not to be extremely powerful or expensive. The pretreatment compared to the multiple effect or to the other system, it's quite poor. As we say, the important is to remove silica, chlorine, chloramine, and hardness. And typically, when we have 200 microsiemens, you can enter in the machine. And it's quite flexible in the production. It's quite flexible in the flow rates and temperature. So as we have seen that we can produce also cold WFI, we have a certain possibility to set the range of capacity, for example, from 70% to 100% of the machines, which has the disadvantages. High initial investment is a technology, even removing the part related to the pretreatment is normally, again, we are talking about we are generally speaking, so talking about the 80% of the cases, is a technology that is normally some higher in investment compared, for example, to the multiple effect remaining in the distillation families. That usually is also compensated by lower operational cost. It's high in electrical energy consumption compared to the other two technologies. In any case, even if it is steam heated, because you need to run the compressor itself, and it has a high consumption. It's quite big, so the space in footprint is quite high. The risk of corrosion, as in the multiple effect distiller, is high. There is a rotating part, so the noise compared to the other technology is higher, still in the limit of the rules, and there is a periodical maintenance to be done to the moving part. Clearly, you have to locate it. There are seals and bearings to be changed periodically. These are the last two slides are related to something that can help in understanding over the technology, which are the costs in the results. In this case, it was a seminar in PDA of 2017. In that case, we had still hot purified water, sorry, highly purified water in hot condition, and they calculated that more or less the hot purified water, so not the cold WFI obtained by membrane, but in the cases that you have to heat up the membrane WFI as it happens in the distiller, maybe for a microbio or for application. And you can see that the multiple effect distiller from the OPEX energy point of view is the more expensive, and the hot membrane WFI, we can call it in this way today, and the one produced by the vapor compression distiller have more or less the same cost for meter cube. This is a picture taken from ISP Appendix 6 that show in a more important and complete way which are the total ownership WFI cost for WFI generation. It is including more or less everything. There is the annual capital cost, the electricity, the chilled water, the calibration of the instrument, the internal quality controls, the water, the steam, the various consumables that are required for the machine itself, chemicals, maintenance, etc., and the labor cost. As you see, the multi-column distiller is the one with higher OPEX. The vapor compression distiller is slightly less than the reverse osmosis itself, and the reverse osmosis for PW, and the reverse osmosis with to produce should be called reverse osmosis ADI ultrafiltration to have WFI is some higher in annual cost. Clearly, these are OPEX. They are not considering all the investment that we have seen before. This is more or less an overview on the technologies that are present today in the world to produce WFI. I have nothing more to add. I hope that my speech was clear. If you have any question, we have still 5 minutes. We will be glad to answer to them, or you can contact us through our website or our email at your convenience.
Thank you very much, Francesco, for a very comprehensive and a very clear session. We have a question from Siva Krishna, who asks, do you manufacture thermal energy storage tanks?
We produce vapor compression distiller and also the storage tanks, yes.
And we also would like to point out that Luca is on this meeting as well, and Luca is based in Singapore. If anyone has any queries locally, then they can contact him as well. Does anyone have any questions, any more questions? Thanks, Siva, for your question. Please feel free to unmute the chat, unmute your microphone to ask the question directly if you wish.
Yeah, so I have one question. Is there any like example in Asia we have for the membrane type of Wi-Fi systems? Did you supply anything in the Asia for membrane Wi-Fi?
We had some requirements in Asia, but typically the most requirement we are requiring today, and the installation that we have today are in Europe or Eastern Europe. In Asia, our experience is more related to thermal machines. But we have, I would say that when we talk about WFI generation, we think that the feed water, the raw water characteristics are quite important. And we have seen, for our experience at least, that our customer in India, in Asia, India included, but Korea or other countries are requiring, at least from Europe, the distillers more than the cold WFI.
Thanks for that question, Sanjeev. Does that answer it for you?
Yeah, that's answer. So if no other question, then I can ask one more questions in this technology. Yeah, so compared to like multiple effective distillation, the membrane, does it require like a kind of a standby kind of a cold membrane technology systems? Because in the multiple distillation column, you need to run it continuously. There will be a little time for the change as well, or for the cleaning as well. But in case of the membrane, is it like kind of a how it can be tackled in case of the change of the membrane is required, in case of the washing of the membrane required? So is it like recommended to have one standby, one duty, or something different your company suggests to the clients?
It is the question is quite it is quite smart. As we have seen in the previous slides, the technology is requiring more labor and more attention than the others. Why? Because as I mentioned it before, the WFI is the job, the main difference between the WFI and the PW is the bacteria content. So in Europe, I just give you an example. I hope to answer to your question in this way. In Europe, if you have WFI production through membranes, you have to notify it to EMA, that is our regulatory institute, before implementation. So it's more critical than the other technologies, because as I was saying, boiling is the only way to kill bacteria, the only safe way to kill bacteria. And so all the maintenance, control, the recirculation of the water are typically the same in all the machines. But the reason is that the pharmacopoeia is telling you that the rules are telling you that you cannot have stagnant water in any pharmaceutical equipment, so you have to recirculate it. clearly when you have to make the maintenance, if it is a distiller or if it is a, let's say, a reverse osmosis, you stop the machine, you make the maintenance that can be descaling, cleaning, or changing consumables that clearly are present in the membrane manufacturing and not in the distiller. Then you have to run the machine and waste, in case, the water or discharge the water until the system is not telling you, for example, that the conductivity return to the same. So I don't think that having redundant system is necessary. The main point is, for us at least, the main concern as Europeans is that, okay, you have an energy saving, you have an investment saving, but when you talk about sterile product, probably the simplest way to kill bacteria and control them is also the safest way. As I said before, I would not like to point myself on the technology. The technology is allowed by law, but on how much I have to follow that technology to sleep well, let's say. And I come back to the previous slide. As you see, the labor and the quality control in the reverse osmosis electrode ionizer for WFI is together with the multiple effect distiller, that is the technology that is requiring more, because you still have to control. There is a direct flow from the feed water to the WFI. I hope to have answered the question.
Yeah, good. Okay, thanks.
My pleasure.
Thank you very much for that very detailed answer, Francesco. And
We are
I think
here for that.
that's great. But if anyone has any further questions, please feel free to reach out to us. We will forward the questions on to Francesco and to Luca. And also a link for the recording of this session will be sent to you along with the presentation slides after this. We can also access our video recording on the ISPE Singapore YouTube page, and that will be posted up later in the week or early next week. So without further ado, I'd like to thank Francesco for his time and sharing your morning with us.
I would just to add one thing. Unfortunately, I'm the commercial director. I would say to all the participants, thank you. And in case you need some information, you can visit our website and contact us through Luca or directly through the website. Thank you to all of you for the attention.
Fantastic. Thank you very much. And thank you all for attending, and wherever you may be, we hope you have a lovely evening or day, whatever it is, and look forward to seeing you all again. So we'll leave Francesco to get on with your day now, and hope to see you again soon. Thank you, everyone.
I hope to see you soon and to meet you in person in Singapore quite soon.
Same here. Thank you. Take care.
Thank you.
Bye-bye.
Ciao.
Thank you. Thanks. Ciao, Linda. Ciao, Francesco.
Bye, Luca. Bye.
Bye-bye.
Bye.